The common complaint for New Zealand homes is they're too cold and drafty. But as the weather warms up, there are growing calls for a change to building regulations to stop new townhouses from overheating.
From 6 p.m. to 9:30 p.m, my room sits at 30 degrees.
While the house keeps warm, it keeps hot at the same time.
It's getting dangerously hot. A sauna without the fun. Sweaty, clammy, burning.
We've got, a heat pump air conditioning unit downstairs, but as soon as you start walking upstairs, you get hit with that kind of wall of heat.
Summer, usually a highly anticipated season of beach swims, long days and sunshine. But it's slowly becoming a season people living in certain new builds dread.
It's such an unpopular opinion in Auckland to say, I'm kind of done with summer, but this summer has been really challenging and I'm so ready for it to be over.
The issue of sauna-like apartments isn't isolated to a single city. People across the country are feeling the heat.
So we're 45 minutes in, currently at 53.3.
Danny Rood is keeping tabs on just how hot his Christchurch townhouse gets.
And when it comes to cooling down, the options can be pricey.
She had to purchase reflective blinds to keep the heat from just boiling her room.
We're running the air conditioning unit pretty much all the time.
Actually, I have 2 fans now, both running pretty much like 3 hours.
But the alternative of not spending up large on solutions can mean an end to a restful night's sleep.
So my partner would love to have all of the bedroom windows open and I cannot. And because I can't sleep with just the noise of cars coming past and all that sort of thing outside.
Like at 4 a.m. I'll hear some trains. I'm like, I didn't even know that the trains ran this early.
And with cities building more houses to meet growing market demand, one expert says these issues will only get worse.
You're going to have more exterior noise because you've got more of these sort of community spaces. But also within the house itself, you've got these multiple levels. So you've got noise coming down, through the floor systems as well, and through the walls, travelling all the way down.
Today on The Detail, what if there was a way to get that cool breeze in and keep the loud noise out?
Part of this new research that I want to do is around windows, being able to open a window and effectively have this sort of like transparent acoustic screen which creates sort of a noise barrier but allows, airflow in.
Kia ora, I'm Davina Zimmer and that's Dr. Andrew Hall from Auckland University's Faculty of Engineering and Design. Right now, he's leading a team developing building materials that can block outside noise while allowing air to flow inside.
So, 2 kind of ideas. One is to have this open duct that you can close and open, and so essentially it could be underneath a window, like a big slot, which means that you can have lots of airflow but no outdoor noise coming through. And the other idea is putting it around the windowsills, and the idea is then that you can open a window just normally, potentially just to a certain point, and that'll allow the airflow but no sound.
It's not in our homes or on the market yet, but Andrew hopes it will be within the next decade. Right now, the materials are being tested at Auckland University's Acoustics and Vibration Research Centre, which is where I went to see him.
This is an acoustic metamaterial system, so it has a number of different acoustic components, so resonant components. So we've got Helmholtz resonators, quarter wavelength resonators, these parts here. And then we've got underneath, we've got sort of a perforated panel system, so that basically the holes, how big they are, gives you the sort of the tuning of where the absorption or the attenuation happens. And so this kind of device has been designed to basically absorb a sound signal. So it could be around, say, like a duct system or even just a loudspeaker.
So it's a cylinder shape.
Yep.
It's about, 30 centimetres high, 30 centimetres wide.
Yep.
And it's multicoloured. And you can see you've got all of these different kind of levels almost in there with holes in them.
Yeah, so essentially these little components are like a beer bottle or a Coke bottle. When you blow across it, it makes a noise.
Oh, like the whistle kind of noise, yeah?
And so that's called a Helmholtz resonator. And depending on how big the bottle part of it is and the neck is, you can tune them to different frequencies. It's actually essentially just a mass on a spring, oscillates at a certain frequency and absorbs the acoustic energy. And so the idea is that, so I'm holding it up now and you can see right through it. So it allows, the flow of air flow through it, but it doesn't allow acoustic energy to get through.
The designs of these acoustic systems in the workshop today are pretty creative. There's one that looks like a drum kit, another has a Fanta logo, not to mention the one that's made to look like a can of Heinz baked beans. And while this may be some people's style, Andrew reassures me that when these systems are put into houses, they'll be looking at some more simple designs.
The interesting thing with metamaterials is that it's more reliant on the structure rather than the material itself. So this is just easy materials that are available for the students, so they could 3D print them, laser cut them. But essentially, just so long as you have some sort of rigid kind of wall, it can be kind of any material, and then you can manipulate the size of the components basically to tune them to different frequencies. This is sort of illustrating a number of different techniques in acoustics that you can absorb sound. So we've got Helmholtz resonators, quarter wavelength resonators, and perforated panels. And these are just, say 3 components. Each is really good at doing something at a different frequency. So on the bottom here, we've got these perforated panels. So it's just basically a panel with holes in them, and they give you a really nice broad absorption, which basically means over a wider frequency range, right? So they're really good for high frequencies. But for low frequencies, using this kind of system here, which is the Helmholtz resonators, which is basically a sprung on a mass, they're really good for low frequencies.
Sound frequencies are measured using the Hertz system, counting the number of peaks in a sound wave over a period of time. Higher frequency sounds have a higher frequency of peaks, and vice versa. But we hear all sorts of sounds every day. So when it comes to creating something that's noise cancelling, you need a range of what they call metamaterials that can absorb different levels of sound frequency.
Initially, we're going to really target that white noise, traffic noise kind of sound that comes in. Yeah. So if you imagine you've got your window, and the simplest version we can think of at the moment is having this sort of extended duct underneath. And basically these metamaterials are integrated to where the studs are inside the wall. So normally you have like a panel on one side and then a stud, say like a 4x2 stud, and then a panel on the other side, or the cladding of a house. So you can integrate these metamaterials within that wall system.
Is it a matter of opening and closing them to let the air in and out?
So if you didn't want any air in, you would just have a normal slot to close them. But when you obviously want the air
coming in,
you open it up.
So it would be like almost like a little lever on the side for the person to open it and shut it.
I mean, we kind of have something similar with trickle ventilation at the moment, but usually this is on a millimetre scale, and there's lots of research on the fact that doesn't really achieve what you need in terms of airflow into a house.
Yeah.
So having something much larger, we're talking sort of 100 millimetres, say, depth by a full metre or whatever.
Metre of window. Yeah. So I'm trying to imagine what that would look like if you're looking at a window. So it would almost be like is it like a slider that you then open and you see all of these little holes to outside?
Yeah, essentially.
At this development stage, the device containing the system is still quite big, and you can't really imagine jamming it inside the wall of a home. But Andrew says it's not the way it looks now that's important. What currently looks like a barrel would evolve into something slimmer that would fit under a windowsill in the wall.
So what we just looked at previously was, say, 75 millimetre diameter tube, and then around that tube were these acoustic metamaterials. So you could either have lots of these different tubes coming out underneath the window, so they're just holes in the wall which you can shut for privacy and for thermal insulation, but then you can open them up for ventilation.
While not having the screaming baby next door filtering into your apartment.
But they could also be a sort of a rectangular slot all the way down. I think the ultimate solution would be to just integrate them into windows fully.
Next, we're heading into a very strange room. None of the 6 walls are the same width. The ceiling is on an angle, and there's a massive UFO-looking contraption hanging from it that spins to distribute the sound.
So now we're walking into the reverberation chamber.
Oh, it's quite echoey in here.
Yep. This is our senior technologist, Jana's setting up some curtains at the moment. So we do all sorts of testing in here, mostly for sort of room treatment. People can build walls over there, so between the 2 reverberation chambers. They can build a wall, and we can test the sound insulation properties of that wall.
Okay.
We can also drop this floor down here, so there's a concrete slab at the bottom on the floor, and we can drop that into a lower chamber, and people can build full floor systems, and we can test the floor systems for impact, so people stamping on the floor, that kind of thing.
So you can hear, is that trying to tackle the sound of, like, you know, if you're living in an apartment building, you've got your neighbour who's up at 5 a.m. doing their cardio workouts.
Yes, exactly.
Hearing their thumping.
Yeah, or the excited toddler running around, jumping. Yep.
Exactly.
Yep.
So you can test that here by, this is essentially, this big square in the middle is essentially a fake, right? Like a second.
Yeah, so we can either put stuff on, like, say, carpet tiles or rubber mats and stuff on here and test different products, but we can also drop this whole slab into the bottom chamber, and a company will build a whole full floor with a ceiling and everything, and then we can test that.
Wow.
So one of the big projects we have at the moment in terms of research is looking at granular materials, so things like if you imagine aggregate, so pea metal or sand and sawdust, that kind of thing, and integrating that into floor systems to try and reduce that impact noise through damping, basically.
There's also another concept here that Andrew's testing. They're called static diffusers, sheets of plywood that are about 2 metres long and half a metre wide. One of them has squiggly lines engraved vertically all the way down, creating an uneven surface to disrupt sound waves.
These are attuned to what we call the coincidence frequency. So there's a certain frequency in panels and walls that we have in our houses, around 2,000 hertz, where the sound waves can actually pass through the wall really easily. And the idea is that these basically destruct that.
And so you would use these to build the 4 walls of bedrooms and houses,
instead of maybe your layer of plasterboard or whatever, you could integrate these. And they effectively have less material, but they perform better.
As well as developing new building materials, the facility is also used to test materials from companies like Windstone Wallboards, New Zealand's manufacturer of gypboard. Andrew's pretty confident with the quality of product made in New Zealand, but the government plans to free up restrictions on importing building materials under its Easy Build project. Andrew worries that the urgency to produce affordable homes could push builders towards importing cheaper and inferior building materials to cut costs. Or if they do use locally made materials, he's worried they won't install them properly.
Lots of things like flooring systems, they have small fiddly components like ceiling clips, and if they aren't installed correctly or they're not designed correctly or manufactured correctly, then they can really reduce the performance of floors, so more likely to hear those, the thumping upstairs. And we've definitely seen a lot of that in testing. As soon as you put, say, a screw in the wrong way, it kind of basically short circuits the whole system.
But it's not just stomping feet frustrating people living in new builds. Prateek Navani was really excited when he moved into a brand new rental, until summer came round.
I realised how incredibly hot my room gets. Coming home from work at 5:30, 6 p.m, my room is just a tinderbox. Like, it's boiling inside. I, open all the windows, open the doors, run my fan. Actually, I have 2 fans now, both running pretty much like 3 hours. But because it's in direct sunlight and the room just holds heat, oftentimes my room doesn't cool down until 10 p.m, 10:30 p.m. So I'll just be sitting at my desk and then have like a moth fly in my face and freak out.
Yeah, and I'd imagine that it's also, you have the issue of having your windows open, then you hear a lot more of the noise from outside. Do you find that creates a bit of distraction as well?
Yeah, I'm pretty close to the train tracks, so I hear every single train that goes past. And, I'll wake up from a really loud noise from the outside. But the bigger challenge has been my flatmate who's right below. She complains that it gets really noisy with 2 fans kind of like vibrating on the floor. And she's sleeping right below it. And she just hears like a constant buzzing from my room. So I have to put my fans up on like a little table.
A couple of suburbs away, Brianna Uritich-Gregg rents a new 1-bedroom townhouse. She loves that it's well insulated and warm. But there is one issue.
While the house keeps warm, it keeps hot at the same time. We've got, heat pump air conditioning unit downstairs, but as soon as you start walking upstairs, you get hit with that kind of wall of heat, and it's not as easy to cool down if you've just got a fan or something. Like, it helps, but it's not the best.
What temperatures are we talking? Are we thinking tropical heat wave?
We're thinking humid and like thick air. That's how I feel. Yeah, and it's the thing. I walk halfway up the stairs and I notice the difference. And because when I have my desk, it's upstairs, it's like, oh yeah, I notice like going from up and down if I'm working from home, just how different the temperature gets.
Yeah, that must be frustrating. How do you manage that issue?
How do I manage that issue? I probably don't. I think I just deal with it. The best thing that we have upstairs where it gets hot is that we've just got a little fan that we'll use in our bedroom. Otherwise, it's trying to open up all the windows, trying to get as much sort of airflow into the house as possible. That's probably the best way. Yeah.
When it comes to choosing between sleeping in a hot room or sleeping with noise, you kind of have to sacrifice one for the other?
Absolutely. So my partner would love to have all of the bedroom windows open, and I cannot, because I can't sleep with just the noise of cars coming past and all that sort of thing outside. So yeah, we do kind of keep ourselves locked in pretty tight, and so we compromise with him doing what I ask for, which is have the windows closed.
And what impact does it have on your electricity bill? Do you notice it's higher?
Definitely. I think in the summer it's definitely higher. I've started using the more like dry function instead of the actual air conditioning. I feel like that kind of helps take out that sort of like, dense air. And I mean, I only found that out from TikTok, is if you're putting on the dry setting, that's like a little bit cheaper on your power bill and will help out with that.
When summer ends and things get cooler, the tropical upstairs home office isn't as much of an issue. But the change in seasons paves the way for another problem: condensation.
It feels a little bit concerning when I kind of wake up in the morning in the wintertime and open up the curtains and just the windows are wet. You see the water dripping down, and you see the little black marks along the windowsill, and it feels strange to be in a new build and to have that happen. I was used to that kind of happening in an old flat where, the windows aren't sealed properly and they're pretty old, but in a new build it's like there's no release for anything. So again, having to keep the windows open during the day, which is hard if I'm working from home and it's the winter and it's cold, that makes it a bit difficult. It's trying to keep on top of that sort of stuff so that the mould and things don't get worse.
And according to Andrew, these kind of issues are only going to get worse as cities build more homes for our increasing population. He says using quality building materials tried and tested in New Zealand is becoming more important.
Because we're looking at, townhouses with multiple levels, and I don't think we're kind of, used to that. But even just like simple things like if you say a piece of plasterboard, I talked about the coincidence frequency, which is this sort of dip region that happens, and that's related to the stiffness of the material. So if you just buy a piece of plasterboard from some other country or whatever, it might have some fibers or something inside the material that you don't know about. That makes the system stiffer, and that means that it lowers the coincidence region into an area where it's more related to speech. So then it can become an issue and it reduces the performance significantly.
So that means that it's not as soundproof.
That's right. Yeah. The sound insulation is not as high. And even though, the material might feel and look exactly the same, without that testing and knowing those material properties, we could have issues in the future.
The materials Andrew's team is working on, which allow for cool air to flow in while keeping noise out, are a world first.
You've got your mechanical ventilation systems, which I guess perform adequately, but they're quite costly to install and cost money to run all the time as well. So a passive system that can be sort of integrated really well into the house, I think, is key. The other thing with these metamaterials is the idea is that we're trying to make them as small as possible so we have more space, right? So traditionally for sound insulation, especially for low frequencies, you need really big, heavy walls, right? Concrete walls, which is what they use, overseas in Europe and that. But in terms of concrete, it's not particularly environmentally friendly in terms of CO2 levels. And the other option would be having really wide, large walls. So you have the air cavity in between two layers, and that means you're taking up space in the apartment. So yeah.
So that's a gap in the market that you're looking to fill with the products that you're designing.
Yeah, for sure. I think that's only the first level that we're targeting as well as the construction industry. I mean, these materials are ideal for for the transportation sector as well, aircraft industry, space industry, even like headphones. So there's, lots of kind of potential.
You've shown me 2 different developments today. You've shown me the air ventilation and sound reducing cylinder, and then you've shown me the pieces of jib panels. What material do you think is going to be first to actually hit the market?
That's a good question. So we're going to start with doors. The reason for that is we think that they don't perform particularly well at the moment. They are definitely a weak point in a building. Lots of apartments now are going to have doors connecting to communal spaces. Also, it's not a structural component, so it's easier for us to go, okay, let's just make this as good as we possibly can with our metamaterial tools, our toolbox. It also combines both elements, so those acoustic resonators potentially around the edges, but also the panels with multiple layers and, what you saw there. So I think that's definitely... The idea is to start with doors.
Starting with doors. And
so start a little bit more simple.
Simple, and then work your way up to building whole houses. The hardest part is really going to be the windows, because the wider you open your window or whatever, the wider the space, it means that you've got, all the sound coming in, and these Helmholtz resonators, which are kind of acting on the energy coming in, they're not going to really affect the stuff right in the middle if you have this really wide open window. So that's why sort of opening it at a sort of a smaller amount, so that's the spectrum that's coming in, so we can tune them to really target. And the university is working closely with the construction industry, which is receptive to these ideas.
We haven't sort of got anything over the line in terms of a product yet, but I guess that's research, right? If it was easy, then everyone else would be doing it.
That's all for today. The Detail is a newsroom production supported by RNZ and New Zealand On Air. Thank you to Andrew Hall, Pratik Navani and Brianna Juritic-Greek. This episode was produced by Alexia Russell and engineered by William Saunders. I'm Davina Zimmer. Ka kite anō.